Hello guys, today I want to speak about the microcontrollers. Do you know the population of the microcontrollers is much more than the population of the people in all over the world? So this one show you how much this electronic components is important nowadays. Please stay with us in this video. I will explain A to Z of the microcontrollers, families, applications and architectures. Thank you so much. Okay, let's go toward the explanation of the microcontrollers. Actually, the microcontrollers has a in this video you know about what is the MCU, what is the SoC and embedded system, and what's the difference between the microcontrollers and one microprocessor. So you know about the family of them and which kind of the microprocessor actually. So what is the microcontrollers? Very simple answer actually. There is the one small computers is the based on the digitals that show and can process just 1 and 0. So and if I want to explain very simple, the one microcontrollers is the one small computers that has the many parts like as the RAM, like as the memory, E2PROM and flash memory actually. So and of course they have some peripherals like as the ADC, analog to digital converter, or DAC, digital to analog converter, and sometimes they have some communication ports like as the USB and UART and serial ports. So it means the microcontrollers is the very small computers. The base of the core is the processors, but they have the memory, RAM, E2PROM and some communications facility for you that but with the very small actually the power. If in the other word actually the microcontrollers with the one processors, memory and some peripherals is we can use it actually under one embedded system. So let's go for the other slides. The microcontrollers peripherals, it means if you want to add some ports like as USB, serials as I told you, or you want to add the one keyboard or keypad or LCD, anything else like as the sensors, you need some ports that the microcontrollers they have actually. In the one microcontrollers, in this is a slide show you, there is the one microcontrollers, inside has the RAM and of course the microprocessors inside it for the process all of the data, procedures of the input and output, and they have the many ports and some things like this, like as the for example the ADC, DAC as I told you. It means for example there is the one computer you don't actually they don't need add anything else like as the memory. But the microprocessor is not like as the microcontrollers. Microcontrollers has the very small with low power actually, and is the produce that you put it inside any appliances like as your camera, like as your home appliances. But the microprocessors is very strong and is very fast, and of course is expensive as well. You for example the microprocessors they put it in the graphic card or your like as the CPU in your laptop and your PC. So what's the difference between them is the price, and of course the microcontrollers is designed for the low power. They designed very simple, but the CPU is very complex and they have usually the CPUs don't have the peripheral and you must to add. For example, your PC have a RAM, have a HDD or SSD like as the RAM, but your microcontrollers no is very cheap and they don't need to add this one because all of these parts is inside this kind of the microcontroller. So about the history. Really, the microcontrollers is started by the Intel by the 8051 number, and in the in the 1985. This one is the one revolution about the microcontrollers that started by the Intel. But the one company under name of the AVR and the company name was the Atmel start the AVR family in 1996. There is the one company and the name was the Microchip is also under name of the PIC. They start with and they compete with each other and they develop this technology actually. And after this one, the next family is the ARM family, is the advanced RISC machine or ARM. The ARM family is the much more stronger with the higher pin. I will explain it in the next slide. But which company actually they produce the microcontrollers? One of them and one of the most important them is the Microchip Technology. One of them is another one is the SD Microelectronics, NXP Semiconductors, Silicon Labs and Texas Instruments, and of course in the next level and in the FPGA, Xilinx and Ultra also they produce the FPGA. So in the next slide I will explain what is the system on the chip. The system on the chip is the other name of the microcontrollers, especially when you have anything inside the one microcontrollers. As you can see, as I told you, the I/O input and output pins, RAM, and of course the CPU, RAM, and they have the one internal clock because all of these parts should be synchronized with each other with the clock actually. So there is the one MCU. MCU means, for example, your processors, and all of these parts is connected based on this MCU, and MCU can manage all of these parts. Please don't forget the microcontrollers is designed for the low power consumption actually. So, and about the microcontrollers architecture, it's very simple because we have the two parts. One of them is the CISC, is complex instruction set computers. This one is for the first stage of the microcontrollers, like as the AT55 as I told you, or Z80. This one has actually many commands. You must use it near to the AT commands, and the opposite of this architecture we must use the RISC. This one is very common now, and all of the microcontrollers use this kind of the architecture actually. Why? Because with the very low commands and they can use the high level language usually. So as you can see here is the 80 commands, and this one is just 30 commands. It means the working and the programming with the RISC actually is very easier than the other architecture. And about the programming, we have now we have the many language to program the microcontrollers, but the usual one is the C for all of them actually, and the other one is, for example, high level programming. It means, for example, something like Python and JavaScript. And don't forget this one. If you come to the high level programming, and your microcontroller should be very slow in comparison to some basic programming like as the C or assembly. The speed with the assembly or C and C programming actually is very faster than the other one. And if you want to write the program, for example, like as the Python, one language like as the Python, please consider this one. You must use high and advanced microcontrollers. And the other one is actually I must speak about the microcontrollers bit. We have the many microcontrollers, 4-bit, 8-bit, 16-bit, and the advanced one actually, and the advanced and complex one is the 32 and 64 bits. It means if for example you use the 4 bits, what's the difference between the 16-bit? One, the number of the buffers, of course, in comparison the 4 to the 16 is the much more. The speed is the higher, the pins is about the pins is the much more than the, for example, the 4-bit. And if you imagine, if you want, for example, the eat lunch, if you have the one spoon with the very small spoon, then your process in your mouse is much lower than the one bigger spoon. Of course, the space of your mouse and number of your teeth and everything should be compatible with the bigger spoon actually. So this one is the comparison between the 4, 8 and 32 and 60 for microcontrollers. The next slide shows you the difference that and actually the 8 bits with the 32 bits. What the difference, of course, the cost and simplicity and some things like this, all of them in the first stage is the 8-bit and in the 30-bit, 32-bit actually use it for the large system, can do the any mathematic processing and more I/O, more memory and something like this. And of course they have this some things they are common with each other, like as the security and a small size and of course the code space efficiency. About the other things about the microcontrollers and microprocessors, what's the difference between? Actually, as you can see, the microcontrollers they have the anything inside it, as I told you, different parts and different block like as the ADC, DAC, USB, UART and power management, and of course there is the one processes also as well. But the CPU don't have this one, and they have the ALU parts, and of course there is the one clock inside it because of the synchronization of the all of the parts, and like as this one. In the other word, the processor just do the process, nothing else. But the microcontrollers do everything, but with the small, actually the processing power. And the next one is the microcontroller family, and they have the many microcontroller family. First of all is the AVR and the PIC. What is difference between the microcontrollers of the AVR, PIC and ARM, FPGA and some of the other microcontrollers, for example the Holtec or Texas Instruments? AVR and PIC actually they join to each other, and now we have the just one company. But we have the three family for the AVR. One of them is the classic, one of them is the 8020, and other one is the Atmega. One is the classic is start by the 80, for example the 90, and other one is the 80 tiny, is the very small microprocessors. It's the microcontrollers, and you can put it, for example, like as they have 8 pins. And the other pins and other families, the very important is the Atmega, because the Atmega is much more popular between the programmer and coding for the coding, and they have the many models like as the Atmega 4, 8, 16 and 32, and these numbers in the end, for example, just show how much the flash and how much space they have for your program. For example, Atmega 8 just have the 8 kilobyte flash for your program. And the another family is the Holtec. Holtec is the very small and actually the low price and is very cheap, but is the difficult actually for the programming. It's very good choice for the production of the, for example, one manufacturer line actually, like as the factory actually. So this one is the, as I told you in the conclusion, the Holtec is the cheap, is a little bit complex about the programming because it's the use like as the C and assembly, and after that is a very good choice for the production actually. The other one, and is the one of the most important family, is the ARM. ARM has the two company produce this kind of the microcontrollers. One of them is the NXP and another one is the ST Microelectronics. So the microcontrollers of the NXP is start usually by the LPC, but the STM is start by the STM, and after that the number of the bit, for example the 32 or the 8 we have as well. The ARM they provide many pins for you. They consider any communication systems based on the how much, for example, I2C you want, how many and how kind of the USB do you want. So based on this one you can choose your ICs you want or microcontrollers for your project. It means they have the processors, they have many pins, they have many options for communications, RAMs and flash memory and some things like this, of course with the different prices. So the next generation of the microcontrollers tend to the ARM technology actually. Actually, for example, if you have the 7 inches LCD with the touch, they need the too much pins. Of course, the AVR and the PIC or PIC cannot, the processor they are weak, and they can, for example, support many communication ports. Some of the, for example, the I2C, CAN bus, many memories, and of course for the some processors like as the image processing or signal processing, then the best choice for you is the ARM. And of course the price is comparison to the other families like as the microchip technology, like as this one, as I told you in the first step, AVR and the PIC. The price of the ARM is the much more than them, but is the based on how your project need the power and market availability, price and number of the pins, and how much the processing do you need. For example, if you want just you manage some sensors and show it in the very simple LCDs like as the characteristic one, then don't need to use the ARM, because you must to pay more, and of course the design and the programming is much more complex in comparison to the AVR and PIC. If you need the much more power for the image processing, signal processing, and you need, for example, manage many communication from the different ports, this one need too much processing, and the processors of the ARM technology and ARM architecture actually is the better, and you must to use it. We have the many microcontrollers with the special application, like as for example there is the one microcontrollers is just for the manage the touch screens, or they use for the just for signal processing, for image processing. The Texas Instruments is also have the many microcontrollers, especially in the DSP or digital signal processing. So based on your request, you can find your best microcontrollers and with the best ability as you wanted, because if you want to use the if you don't use the specific one, you must to write the program too much. And after that, the other families is not microprocessors, but they have the actually is the processors. They have many power, they are very fast, and of course they use it in the medical and the military and in the communication. Actually the processing is the FPGA, two important company actually they produce this kind of the chips, like as this kind of the microcontrollers, not the this one is the actually is the like as the processors. You can make the one processors is the FPGA. FPGA is the very fast, as I told you. Two companies like as the Ultra and the other one is the Xilinx produce this one. The FPGA is like a Lego, and you can find and you can make by programming in these Legos actually, and the application is based on you, but in comparison to the ARM is very expensive because of the technology, because of the pins, and of course you cannot use it individually because they have the BGA package, and you must to buy the boards in the advance. For example, designing, you can use your PCB for your application and your design. And the other one is the application of the microcontrollers. Now the microcontrollers penetrate to any field that you can see in all around of you actually. One of them is the robotic. All of the process of the sensors, commands, anything is based on, in the robotic is based on the microcontrollers. And the other one is the smart energy, other one is the communication, lighting, manufacturing, and the car automation, especially the electrical cars. All of the powers and the sensors monitored by the microcontrollers. And how about the other things like as the airplane? Of course they have the microcontrollers because there is the one central processing systems, because of the all of the sensors should be processed and sent to the central processors and CPUs. So this one is the microcontrollers, and hopefully all of this explanation was beneficial for you. Now you must to know what's the difference between the microprocessors and microcontrollers, and which kind of the microcontrollers you must to use in your project. So you must to know about the why you don't put your laptop inside your refrigerator or laundry or any home appliances, and you use the microcontrollers. What's your idea about the Arduino, Raspberry Pi, and your cell phone? Which one use the microcontrollers and which one use the microprocessors? If you have any question, please drop the one comments under this video to answer you as soon as possible. Thank you so much.